Hello, future leaders. This is a video about chemistry on November 4th. Okay? Alright, so let's go through this. Now, um, we reviewed protons, neutrons, and electrons. Protons and neutrons both have an atomic mass of 1. So we call that atomic mass unit. Electrons have a very small mass, 1/1840th of an atomic mass unit. So they're a very small fraction, the mass of a proton or neutron. Protons are positive and in the nucleus. Neutrons are neutral and in the nucleus. Electrons are negative and they're outside the nucleus. All right. And then that's the same thing. All right. The nucleus is the protons and neutrons. So we have 2 protons here and we have 2 neutrons. Okay. And then the electrons go outside the nucleus. All right, we might call that the electron cloud, or you might say this is the first energy level. Okay, now the atomic number is the number of protons. So this has 2 protons. So what's the atomic number? Right, it's 2. All right, protons and neutrons equal mass number. So if I take the number of protons and the number of neutrons and add that together, that gives me the mass. So I have 1, 2, 3, 4 particles in the nucleus. So my mass number would be, right, is 4. Okay. Now here we have the mass number. So we have protons and neutrons. So the mass number would be 4. Now, if I subtract the atomic number is the number of protons, so that means I have 2 protons to subtract. So if I have protons and neutrons and I subtract the 2 protons, that leaves the 2 neutrons. So if you take the mass number of an isotope and the atomic number and subtract them, you will get the number of neutrons. Okay? Now, as a side note, we said before, in a neutral atom, and this would be a neutral atom, okay, then protons equal electrons, right? So let's go, let's go here. All right, so this number up here, this is a superscript because it's above the writing. That is the mass number. And in this notation, it's always going to be the mass number. Right, so this is the mass number of this isotope. And then down here, this subscript, which is below the writing, okay, that is the atomic number. And again, in this notation, it's always going to be the atomic number. Now I'm going to go back here for a second. We could also write this as helium-4, 4 being the mass number of the isotope. He-4, again, 4 is the mass number of this specific isotope. Now, we could have an isotope with a mass of 3, and we could have an isotope, this is hydrogen, with a mass of 5. That would be really weird. I'm sure that is supposed to be helium. So I'm just going to erase that, and I'm going to put in, I can't see. Here we go. There we go. That's helium. All right. Now, we're going to go back here a second. And so this is the mass number of this isotope. And this is the mass number of this isotope of calcium. Ca is calcium. And we have the atomic number down here. Notice the atomic number for calcium is always going to be 20. If the atomic number is anything else, it's not calcium. All right. Now, the word isotopes, iso means equal, and tope means place. So what that means is that these isotopes of calcium have the same place on the periodic table, right? Because they're the same element. They have the same chemical properties. They just have a different number of neutrons. Now, how do we know they have a different number of neutrons? Well, if the mass is 38 and we subtract 20 protons, that's 18 neutrons. If the mass is 40 and we subtract 20 protons, then the mass is 20. Okay? All right, and we talked about that. All right, so again, protons plus neutrons equals 4 for this isotope, so that's the mass number. The protons equal 2, so that is the atomic number. All right, and anytime we take the mass and subtract the atomic number, that gives us the number of neutrons. All right, and I think that's just about it. Sorry, I had a plan. All right, and then we talked a little bit about ions. So an ion is any atom that has a charge. So if we take, for example, lithium normally has 3 electrons. So 3 protons and 3 electrons, that's 3 positives and 3 negatives. So that's a neutral atom. But sometimes it loses an electron. So when it loses an electron, then you have 3 plus negative 2, so that's a positive 1. So that's a positive ion. All right? And then if we take fluorine, fluorine has 9 protons and 9 electrons when it's neutral. But because 7 of those electrons are in the outer shell, then it's much easier to gain 1 than lose 7. So fluorine tends to gain an electron. And when you gain electrons, that means you have 9 positives and 10 negatives. So that if you add those together, you get negative 1. So that is a negative fluorine ion. All right? And then we talked about weighted averages. So if you have, these are your test grades, they average out to 85. But that 85 is only 60% of your final grade. And then if these are your informal grades, they average out to 90. But that's only 40% of your final grade. So you take the formal average, multiply it by 60%, or 0.60, that gives you 51. You take the 90 for your informal average, multiply it by 0.4, and that gives you 36. You add these together, and your final average is 87. Okay? So that's how a weighted average works. Just like your grades are a weighted average. So then when we need to calculate the average atomic mass, this is the mass on the periodic table. Okay? And so the mass number is a specific isotope, but the average atomic mass is an average. It's a weighted average. So we take the mass of the isotope, multiply it by the percentage that we find it. Like if we have a big balloon of carbon, and we can measure how much of it has a mass of 12 and how many atoms have a mass of 13, 98.9% of it would be a mass of 12, and 1.1% would be a mass of 13. So we say 12 times 0.989, and we take 13, multiply by 0.110, and these are the numbers that we get. We add these together, and we get the 12.011. Okay? Don't forget your sig figs. All right, so that is that. Let's see here. I'm going to pull out the old calculator here. So if I have 11.87, back that up. Oops. All right, 11.87 plus 1.69. It's going to give me 1356, which is not correct. I'm confused. Anybody got, so 13 times 0.11 is 1.43. So I must have added something wrong. And then 12, oops, 12 times 0.989 is 11.86. So then we say 11.87 plus 1.43. That still gives me 13.3, which is not even an answer choice. It's got to be the 12. There must be an error in the percent abundances, but still, that's how you should work it out. All right, I'll take a look at this question in more detail. You have a CK12 that you need to be working on, and I'll see you in class.